So we're going to take a look in Chapter 2. Chapter 2 is really like a combination of two Algebra 2 chapters. It's the combination of polynomials and rational functions. So quadratics are a subset of polynomials, so that's where we're going to start. And then tomorrow you guys have graphing worksheets that you're going to be working on. And so one homework assignment, bring your graphing calculator tomorrow if you have one, so that you can use that in class. And we'll be kind of investigating some polynomials there tomorrow. And then we'll end the chapter with rationals, which are those fraction ones we saw previously. So we're going to talk about quadratic functions and models. Mainly, I don't know why my last things don't work today. Mainly, we're going to talk about quadratics, the basics. Oh, at the end of the period. I gotta make sure I get through my notes. Okay, so polynomial functions, just as a whole, are a large set of functions, a family of functions, that can be classified by degree. Do you remember specifically what degree means? Abby?
Like extra of this would be differently, right?
Yes, and what is the degree in a polynomial that has lots of terms? Like what if it's like x to the fifth plus 4x, the highest exponent, right? So maybe make a little note to yourself if you need to. A degree is the highest exponent. I'm lazy, so that's my abbreviation for the word exponent. I just don't want to write it all out. Any abbreviations. If you're ever wondering what I'm writing, if you don't like my abbreviation, you can write out the whole word. Okay, so she said like x to the fifth is a fifth degree, and some of them even have actual names to them. So if you have x to the 0, do you remember anything raised to the 0 always reduces to just the number 1? So then x basically goes away. You don't have a variable, so your function does not vary. It is constant. Okay, so x to the 0 or no x would be a constant function. And then we have a few names as we move up. X to the first is linear. X squared is the quadratics. X cubed is cubic. Anybody remember fourth or fifth? Quartic. And quintic.
Oh my gosh,
Yep. Now, at some point, we stop naming them and we just say, sort of like Abby did, like 6th degree, 7th degree, 8th degree, 9th degree. Remember you did that in geometry? Up to a certain point, you had like a decagon, dodecagon, and then you were just like 13gon. So quadratic functions are the ones that are x squared, degree of 2, so highest exponent is 2. And I like what you guys said in the warm-up, they're always going to be parabolas. Now, as we progress to like tomorrow when you're doing the graphing calculator activity with polynomials, know that as you go to cubics, quartics, and higher, you're not always guaranteed the same shapes, right? The polynomials can take the different terms. So parabolas, quadratics are kind of nice because they're always that same shape. And quadratics are awesome because they can model for us like things that go into the air and come back down. So think about all the different things that we could use a quadratic model for in the real world. All right, some characteristics of quadratics. You should be able to identify if quadratics go up or down, open up, open down. Does anybody remember how you can tell? Positive or negative in front of the whole function. So I'm going to put up an equation for a quadratic and see if this looks at all familiar to you. A times the quantity x minus h squared plus k. I should hope so. Okay. Or f of x equals ax squared plus bx plus c. Both of those are quadratics. their highest exponent would be 2. So when I say that it opens up or down, like Paige said, positive or negative in the front, it would be like, is your A positive or is your A negative, right? Positive A is going to be a parabola opening up. Negative A is going to be a parabola opening down. Yes, Paige? K is the vertical shift. Okay? It would be in this, in the first one, A would be a vertical stretch or shrink. This one doesn't have transformations. It has the A, B's, and C's, so it's just a coefficient for this. Vertex. You'll either have, and I love that you guys did this in the warm-up, a maximum or a minimum. When will you have a maximum? When A is negative. When will you have a minimum? When A is positive. So negative A and positive A. So you also know when you're going to have maximum and mins, just looking at your function. Do you remember from either of these equations how to find the vertex? If you plug in 0 for x or y, you'd be finding one of the intercepts. Paige? Do you remember this? HK? H always looks like the opposite of what it really is. If it says like x minus 3, it's actually positive 3. Okay. So HK is your vertex. There is a way to find the vertex in ax squared plus bx plus c, but I'll tell you starting off right here, we are going to concern ourselves more with the other form. So I focus on HK. Do you remember talking about an axis of symmetry? Can somebody describe to me what the axis of symmetry is or does? Somebody I haven't heard from yet? What's the axis of symmetry do? Laura. The axis of symmetry will pass through the max or the min. Very good. So I'm going to draw a picture of the axis of symmetry. And here's some parabola, right? And the axis of symmetry is a vertical line, passes through the max or min, and if you fold the parabola on the axis of symmetry, it maps onto itself, right? And that's what the line of symmetry would be. I use the abbreviation for axis of symmetry. I call it AOS. So don't write the whole thing down. And then, if you know your vertex, your max or your min, you automatically know your axis of symmetry. It's the vertical line through that point. Vertical lines are written as x equals, and remember this is HK, so it would be x equals, you always know your axis of symmetry. And then the last characteristic that we're going to talk about is x-intercepts. Can anybody tell us how you would find the x-intercepts of a quadratic? Abby, you can factor. Okay, one way is to factor. What are you doing before you factor? Like to the equation? Setting the equation equal to 0, right? I mean, like really in the definition of an x-intercept, we should say something like set f of x, or you could think about that as y equal to 0. And solve for x. Now, Abby gave us one method, factoring. What are some other ways to solve for x? Quadratic formula? Anything else? Factor by grouping could be a way to solve. If it does, okay, so those would both work for ax squared plus bx plus c, factoring in quadratic formula. But remember, I'm going to focus most of my time on this other equation today. So if we're in this other equation, we can use reverse PEMDAS, because we just need to get the x all by itself. And then some of you might also know for this other one, completing the square, which we are going to talk about, but in a different sense today. You got a question? Were you going to say complete the square?
No.
Oh yeah, for 0 and for y and solve for x. Very good. Now, could you also find the y-intercept? Yeah, how would you find the y-intercept? So 0 and for x, and then just work out the equation. So that would work out really nicely as well. Here's an example of something that you might be asked to do tomorrow. Or not tomorrow, but on your homework. I got distracted by Mr. Johansson. Yes, if I fall outside. Everybody can just stare for a little bit if you want. Okay, write this down while you're staring.
They can, and they will, do comment section. We'll have left and right opening paragraphs, but not here, when we're opening something else. Function form, writing
Okay, so one thing you can do to graph quadratics, obviously, is to use transformation. So, like on your test that you took yesterday, you already graphed the quadratic form, so you know some stuff. The thing that you want to focus on in chapter 2 is we're maybe going to pay attention to a few more details of the quadratic. So when you're doing your homework tonight and then we come in and we check homework tomorrow, we want to make sure that you have the correct vertex, ordered pair, you have the correct equation for the axis of symmetry, and that you have exact values for your intercepts written as ordered pairs. So we'll kind of run through an example here so you can see what that would look like. So I've got f of x equals quantity x minus 1 squared minus 3. Can you, from that equation, give me the vertex? Yes, what is it? 1 comma negative 3. Remember, h in the equation always looks like the opposite. K looks like what it really is. Okay, so 1, negative 3. If you have the vertex, you also automatically have axis of symmetry. What's your axis of symmetry? X equals 1. That's one of those things Ms. Crosby's going to be picky about, so that you have x equals right there. And then we're also asked to find the x-intercepts. How would you find the x-intercepts? Set f of x equal to 0. So 0 equals x minus 1 squared minus 3. And then solve for x. So think about some steps you'd take to solve for x. First, you would add 3. So 3 equals the quantity x minus 1 squared. Then square root both sides. And always remember, when you square root to solve, this will turn into a plus or minus square root 3. We don't know which one it was. So that's equal now to just x minus 1. And we're very close to our x-intercepts. Add 1 to both sides. Okay. So you should write your x-intercepts. I'd like to see it in an exact value. Exact value would mean if it's got an irrational number, which is a radical. Make sure your radical is simplified. The square root of 3 cannot be simplified, but leave it alone. Don't give me a decimal. That's not exact. You've rounded it at that point. And then the only thing you would do here is use this to write your ordered pair. So your ordered pair for your x-intercept would be 1 plus or minus square root 3, comma 0. X-intercept will always be the x value, comma 0. Okay.
write it like the positive and negative
You could. It's just very common if you think about like the way that quadratic formula works out, opposite be plus or minus the square root of. The solutions look like that, 1 plus or minus the square root of 3. But the plus or minus would still be in front of the square root of 3. So it'd be plus or minus square root of 3 plus 1. So you do square root of 3 plus 1, negative square root of 3 plus 1, which is the same as 1 minus square root of 3. I like to write mine like this because this is how you would see most solutions. Okay, now I realize that when you write this out as an exact x-intercept, like if you go to your graph, that's not super helpful, right? So if you're graphing it and you want to put those x-intercepts on your graph, by all means, go to your calculator or estimate it. Like, I know the square root of 3 is 1.73. So 1 plus 1.73, I'm going to have my x-intercept is 2.7 on the graph. Let's graph it. I draw my vertex at 1, -3. I'll draw my axis of symmetry. So that my vertex is like my shifting, my transformations, right 1, down 3. If there was a vertical stretch or shrink, if there was a value for A, then I would apply that here. Instead of going up 1, right 1, I would do whatever that A value was for my first point. There is no A value, so I can just go up 1, right 1, up 1, left 1. I can also, for an even more accurate graph, like I said, estimate my x-intercepts. 1 plus the square root of 3 is like 2.7. 1 minus the square root of 3 would be -0.7. Notice these things should be equal distance from your axis of symmetry. And then you can draw your parabola. Tomorrow when I go over the homework, I want you to be able to check those things. I want you to be able to say, I have the right vertex. I have the right axis of symmetry. I have the right x-intercepts. And my graph looks like it's in the right spot. Macy.
So how do you graph 0, -2, and then 2, -2?
Because I know from the parent graph of the quadratic function that if there is no vertical stretch or shrink, from the vertex to the next point will always be up 1, right 1, up 1, left 1. If there's like a vertical stretch of 3, then you would go up 3, right 1, and that will make your parabola narrower. If there was like a vertical shrink of 1/3, up 1, right 3. So it's kind of like slope, but it only works for the first set of points. You can't use it again, right? Any other questions that I should answer or clarify? Okay, good. So just kind of be aware of what's expected for your homework. Could pop up on the problem set. You'd want to make sure you have all 4 of those things. Okay, now I want to just have you write this down. In Algebra 2, you would have called this form vertex form. And it makes sense to call it vertex form because the vertex is right there, right, HK? The algebra or the pre-calculus textbook calls it standard form. Okay. Isn't that funky? Sure. Bye. Abigail, take this gold sheet. She knew it was coming. Okay. So the pre-calculus textbook calls it standard form. Just be aware of that. When I say now in pre-calculus, write it in standard form, I mean this with the A, H, and K. So that'll take just a little bit of getting used to. That's what I was looking just now in my textbook to see if they called it something, but they just call it the quadratic function. I guess I would call it maybe like a general form.
That's what I've always.
Yes, I agree. And that's why I'm clarifying on this slide that we're now calling A, H, and K standard form. I dislike that. I would prefer to call it vertex form, but such is life.
So are you going to give it a
I'm going to refer to it as standard because that's what the textbook does. Like in your homework, And on quizzes and tests, it'll say write it in standard form. Now, some of the problems in your textbook are going to ask you to do this. Take a quadratic function and look at that function, f of x equals x squared minus 6x plus 5. That's in what you would have been your old standard form. And write it in standard form. They mean the new one, the a, h, and k. So write it in standard form. F of x equals a times x minus h squared plus k. After you do that, your textbook is going to ask you to do the same things we did on the previous slide. I've got them here on the directions. We're not going to take the time to continue to graph and do all that for every quadratic. Now what we want to focus on is the rewriting piece. Okay, but just be aware, after you rewrite it, then you can do the same process we did to get a new graph. Did you have a question? Good. I have one hand. It looks like it's written there. Now maybe I'm just going to select this. Okay. We are going to rewrite ax squared plus bx plus c into the new standard form through a process known as completing the square. Yeah, the best. Does anybody remember anything about completing the square? Lauren does. What do you remember?
You either divide the 5 or the 6 by 2, you like square it, and add that number to both sides. I don't think A on the C. Because I did it on the summer packet, it's in the problem.
That's factoring. Tatum, you're saying what?
What she was saying is C and you divide by 2 and you put it on both sides of the equation.
It's C, so you want to do it with 5.
So 2.5 times 2.5.
No, it's C.
I don't remember.
Okay. So, in order to complete the square, first of all, let's just talk about what it means. To complete the square means you're going to make what is called a perfect square trinomial. Trinomial has 3 terms, right? Like ax squared plus bx plus c. You want to make a trinomial that when factored has the exact same 2 factors, because that's what a perfect square is, right? 5 squared is 5 times 5. It has the same 2 factors. So we want to create a trinomial that has the same 2 factors. So in order to do that, we're going to not look at the c value, but we're going to focus on the x squared and the x term, and we're going to complete the square for those. So something that you might have done in Algebra 2 to kind of help you isolate that is move the constant to the other side. Would you be okay with that? Okay, let's move the constant to the other side. Now, in years past, I've done it different ways. And so you don't have to move 5 to the other side, but I think a lot of people will find a little bit more success by just getting it out of the way. So we have f of x minus 5 equals x squared minus 6. And now we can do what Lauren said and Tatum agreed with, which is find the number that completes the square. So this is what you learned in Algebra 2, and hopefully you picked up on a pattern. And Lauren said you do what?
You divide -6 by 2, so you use -3, and then you square root that, so you'll have 9, and then you add 9 to both sides.
Square root?
Square it.
Square root. Square. Okay, so it's I always say this, half of the middle term squared. That's how you complete the square. Half of the middle term squared. And it's really just half the middle term's coefficient squared. You don't really worry about the x. So she's saying that the number that should complete the square is 9. So then what do you do with 9? You add it to complete the square. Since you added it on the right, you have to add it on the left. Okay, so plus 9. Are we all okay with this so far? Maybe.
I'm just a little confused why you didn't make
That is, so in this x squared minus 6x plus some constant, 6x is the middle term. Like the ax squared plus bx plus c. So it's really like half of b, the x term. So that's where the negative 6 is coming from. You take half of that and then you square it.
Okay, and then I'll see if,
The number that completes the square. Okay, and then we end up with f of x, what, plus 4? Equals, now think about this trinomial you created. If you factored x squared minus 6x plus 9, what are factors of 9 that add to make negative 6? Negative 3 and negative 3, so it would factor out as x minus 3 times x minus 3, which we can just write as x minus 3 squared. Cool. Okay. And do you see how we're getting closer to this blue form? We got the squares now. The only thing we have to do is subtract the 4 from both sides. So subtract 4 from both sides, and you will have f of x equals x minus 3 squared minus 4. Cool. So could you now do vertex? 3, negative 4, x is the symmetry at x equals 3, set f of x equal to 0, add 4, square root, add 3. You could do all those things and then graph. Okay. How are we feeling about this? Is refreshing or a refresher? Okay, now we gotta do one that's a little bit different. Let me watch my time here. F of x equals 1/4 x squared minus 2x minus 12. Tell me something that is different about this problem. The coefficient in the very front. That's going to cause a problem for us, whether it's a fraction or another number. So talk to me about some things you would do to start rewriting this with completing the square. I would probably move that constant, right? Instead of minus 12, I would add 12. Because you cannot, well, you could complete the square of 12 over there, but like I said, I think most of us will do a little bit better. But we really want to focus on just the x squared and the x term. And Paige, you say? Well, you know, that's not interesting. Someone else said that last hour, and I said no. We'd end up with an f of x divided by 1/4. I'd have to try that on my own before after school and see if that will work out. I'm not going to lead you that way just because I don't know how it will end out. But I'll look into that because someone else suggested that. But we don't want to have that 1/4. I agree with that. So besides dividing by 1/4 and moving it on like both sides, what else could you do to get the 1/4 away from the x squared? Take out a 1/4, and at least kind of means factor out a 1/4. So that's what I'm going to say to do. I'm going to show you that, and I'll do some experimenting with this other thing and see what happens. So on this side, f of x plus 12, we can kind of just like let that sit there. And over here, we're going to work to factor out a 1/4. Now, if there was a 2x squared, then we would factor out a 2. I, of course, learned doing example with fraction because people have a hard time factoring out the fraction. So I'll show you how you can work that. Okay, take out a 1/4 from 1/4 x squared. What's left over? X squared, because essentially you're doing 1/4 x squared divided by 1/4. That's what factoring out is, dividing it away. Okay, but it's still out there. So to factor out a 1/4 from -2, think about this. -2, factor out a 1/4, it's like dividing it by 1/4. If you divide by 1/4, then you're really multiplying by 4. So the middle term is actually a negative 8x. I'm going to get a lot of people when they factor out a fraction who are going to tell me 1/2. And how can you check to make sure if you're right? Just redistribute this number real quick. It should go right back to what it was before. 1/4 times x squared is 1/4 x squared. 1/4 times negative 8 is negative 2x. If I had put a 1/2 right there, I would have got negative 1/85. So I know something was wrong. Okay, so now that I've removed the 1/4, you can only complete the square if the leading coefficient is 1. Can I complete the square? Yes, what number completes the square? 16. How are we getting that? Half of the middle term, the x term. So that coefficient, negative 8, divided by 2, and then square it. So 16 is what completes the square. Okay, now we gotta be really careful. Because I factored out the 1/4 from the x squared and the x, when I complete the square, I'm also really factoring out the 1/4 from that whole trinomial, so the number that completes the square. I didn't really add 16 over there. How much did I add? Whatever 16 times 1/4 is. What I really did on this right side is add 4. So what do I want to put on the other side? 4. Yes, it will turn into 16. Okay. Yeah. It'll turn into 16. So if you factor something out, remember, like, you're factoring that out of the whole perfect square trinomial. So it's really like protected by that parentheses when you put the plus 16. In order to add to the other side, you got to even it out. You got to multiply by the 1/4. No. Yes. We already took 1/4 out of 16, just like we took 1/4 out of negative 8x and x squared. So this is not really x squared minus 8. This is really 1/4 x squared minus 2x. And so if I redistribute it, it would be 1/4 x squared minus 2x plus 4. I'm really adding 4 right there. I'm not putting it 16. 1/4 times 16. I just redistributed it. Whatever you took out, distribute it to the number that completes the square. That's what you really did. If it was a negative, then I would have subtracted it, and I'd subtract it on the other side. Okay. Now, let's rewrite it. So we've got f of x plus 16 equals, and then we have that 1/4. This whole thing will condense to x minus 4 squared, and then you can write your final f of x equals 1/4 x minus 4 squared minus 6. I think those will be the hardest ones for us when we have to factor something out, especially if it's a fraction. So just kind of be aware of that. If you see it on the homework, make sure that you try it. So that you can check to see if you're doing it right. Okay, we've got one other quick example that we want to look at. And I won't take up a whole ton of time so that I can pass back the test. It says write the standard form equation of the parabola with the vertex and point. So remember, when it says standard form, it means the one with A, H, and K now. So think about a plan for this. If you're given the vertex and a point, what can you do with those things? Plug them in, and then solve for. This will be H, this will be K, this will be X, this will be Y. What's the only thing you're solving for? A. You'll have plugged in for everything but A. So this is like f of x. Okay, so you do 0 equals A times negative 1 plus 2 squared minus 2. I would, whatever the K is, I'd move it to the other side. So I'm going to add 2. And then I'd work this out. Negative 1 plus 2 is 1 squared. 1 squared is 1. So A is 2. And then you can take your A and your H and your K and write your equation. F of x equals 2. X plus 2 squared minus 2. And so it's really just a matter of substitution and solving. Now, you have a homework assignment. Zach's going to be super helpful and pass out a gold sheet to everybody at your pod.